Welcome back for the video for lesson 6.7. We are going to learn about complex numbers. A definition of the number I. So the I is called the imaginary number, and it represents anytime you have the square root of a -1. Because we've learned so far in math that you can't take the square root of a negative number, but we are going to need to be able to do that because of some solutions and how it works in math. And so to do that, we created an imaginary number that will represent the square root of the -1. And then in turn, we can then say that I squared is equal to a -1 by squaring both sides. Okay, so if a is a positive number, then the square root of a -a can always be written as I times the square root of a. So the square root of -a is equal to I times the square root of a -a, because I represents the square root of a -1. So the square root of a -a equals the square root of a -1 times the square root of a. And this is then I times the square root of a. So for example, here in example 1, we're going to simplify these. So this is the same as the square root of a -1 times the square root of 49. And then that'll be I, and then the square root of 49 is 7. And we always put the constant out in front of the I. And then we have the opposite of the square root of a -1 times the square root of 25. So the opposite of I and 5 is the opposite of 5I. Again, we have the opposite of the square root of 81. So this is the opposite of square root of -1 times the square root of 81 is the opposite of I times 9, or the opposite of 9I. And the square root of a -48 is the square root of a -1 times the square root of 48. So the square root of -1 is I, and the square root of 48 has a square root of 16, and the square root of 3. Square root of 16 is 4. So we have 4 times I times the square root of 3. So whatever simplifies evenly comes out as an integer, and then we have the I, and then the square root that's left over is on the right-hand side. Okay, let's look at the powers of I. So if we assume all the properties of exponents hold when the base is I, we can write any power of I as I, a -1, a -I, or 1. Using the fact that I squared equals a -1, we know these are the following. So I to the 1 is just I squared is a -1. I cubed is I squared times I. We know that I squared is a -1 times I is a -I. I to the 4th is I squared times I squared. So I squared is a -1 times a -1 is a +1. So then we can build up further. So then since I to the 4th is a +1, that means I to the 5th is I to the 4th times I, which is just I times I, which is I times 1, which is I. And so it repeats. So any multiples of 1, 2, 3, or 4 will be these outcomes. So take a look at example 2 on these 4 situations and see which of these results it is. I, a -1, a -I, or 1. And I'll be right back. Okay, I to the 31, let's see how you broke it down. I to the 4, I'm going to do as many multiples of I to the 4 as I can. So I to the 4, I to the 4, that's 8. I to the 4 is 24. Another one would be 30. No. I to the 4 is 16. I to the 4 is 20. 4, 8, 12, 16, 20. Another I to the 4 is 24. Another I to the 4 is 28. And then I have an I to the 3. So 1, 2, 3, 4, 5, 6, 7 would be 28 plus 3 is 31. Each of these equal 1 times I to the third. So I have 1 times I to the third. And we know that I to the third is a negative I. So this answer is a negative I. Okay. So if we do the same, we've got I to the fourth. I'm going to take that to the sixth power because just like this would be I 2, 3, 4, 5, 6, 7. This would have been I to the fourth to the seventh power was 1. So I have I to the fourth to the sixth is 24. And so I have 2 more i's. So I have an I squared. So I have 1 times an I squared, and I squared is just a negative 1. So I have 1 times a negative 1 is a negative 1. Letter C says I to the 37. So I to the 37 is I to the fourth to the ninth is 36 times an extra I. So I to the fourth to the ninth is 1 and just I. So that leaves just I. And then lastly, we have I to the 42. So I to the fourth times 9 times 10, or to the 10th would be 40, and then I'll have an I squared left over. So I to the fourth to the 10 would be 1. And then we'll have I squared, which is a negative 1. So that leaves us with a negative 1. That's what we have for those 4. Now we're going to use the imaginary number I to make what's called a complex number. So a complex number is any number that can be put in this form. A is the real part of the number, and BI is the imaginary part. So it's complex. It has 2 different parts, real and complex. Okay. So if we think about the subsets of complex numbers can fall into 3 different categories. We can have real numbers, which is all of it are real numbers, and there's no imaginary part. So there's no BI. Then we have compound complex, where we have a real part and a complex part, such as the real part is 5 and the complex is 4i. Okay. And then we have a third complex number that's just pure imaginary numbers. There's no real part, it's just all imaginary. So we have a rule here for equality for complex numbers. 2 complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. That is for real numbers A, B, C, and D. A plus BI is equal to C plus DI if and only if A and C are equal, the real parts, and B and D are equal, the imaginary. So example 3 says find X and Y so that each of the following equations are true. So X must be 1 because 4X has to equal 4. So X must equal 1. And then the imaginary part of each side must equal. So we can cancel out the i's, and we're going to divide by a negative 2. So y must equal a negative 4 for them to equal. Okay. So now we're going to do the same. 4 must equal 6x. So if I divide by 6, x must equal 4/6 or 2/3. And then 7i must equal a negative 14 yi. So the the i's cancel, and we're going to divide by -14 to solve for y. So y must equal a -1/2. Let's look at letter C. So it looks like the real portion is this, and it's equal to 8. So 4x minus 3 equals 8. So I'm trying to find out what x is. So I'm going to add 3 to both sides and divide by 4. So x is 11/4. And then on the imaginary portion, I have this. So my i's cancel. So y equals a -2. Letter D is on the extra video. We are now going to learn how to add and subtract complex numbers. So to add two complex numbers, add their real parts and their imaginary parts. Okay. So on A, we're going to add our real parts. So 4 plus 3 equals 7. Plus I plus 2i is plus 3i. B is subtracting. So we have to make sure we distribute through that subtraction. So it's going to be 6 minus 4 on the real plus 7i. Subtracting the negative is plus I. So we have 2 on the real plus 8i. C and D will be on the extra video. We can also multiply complex numbers. So when we do, for instance, when we multiply these complex numbers, bi times bi gives us a bi squared. Whenever we end up with an I squared on the complex part, that I squared must always simplify to a -1, because when you multiply complex numbers, you should, if you multiply complex conjugates, you won't have any complex or imaginary part to it. It'll always end up with a real number. Now, if they're not conjugates being multiplied, then you could still end up with imaginary numbers. So we're going to look at some of these on A through F. So we have to distribute through the 2i. So we have 2 times 3 times I plus 2i times 4i. So we have 6i plus 8i squared. So 6i plus 8, I squared is really a -1. And so this is 6i minus 8. And our -8 is real, and that always gets written first. So we're going to rewrite it as -8 plus 6i. The ones I cross out will be on the extra video if you want to check it out. It's not required. So C, we're going to multiply and FOIL. So we have 6 plus 2i. And then the insides make a -12i. And the last make a -4i squared. So we have our constant of 6. We have our like terms. 2i minus 12i is a -10i. And then -4, the I squared is a -1. We cannot forget that the I squared is a -1. So this is 6 minus 10i plus 4. And so this simplifies to 10 minus 10i. So B, C, and E are all going to be on the extra video. Letter F, I'm going to multiply these. So we have 11 squared is 121 plus 77i minus 77i minus 49i squared. So we have 121. Ooh, and it looks like our middle terms add to 0. And you might have already noticed that these are conjugates. Remember that conjugates uniquely have their middle terms add to 0. And then we have a minus 49, and I squared is really a negative 1. So 121 plus 49 is 170. Now, since we have added and subtracted and multiplied complex numbers, we can also divide complex numbers. So the complex number a plus bi and a minus bi are called complex conjugates. I just showed you that on the last piece here. So in order to rationalize the denominator, you must multiply it by a denominator that will create a real number to rationalize it. So in this first one, we have 3 plus 4i over I. So I only need to multiply by I over I because that will create a real number. So we have 3i plus 4i squared over I squared. 3i plus 4. Now the I squared on top is a negative 1. And then my I squared on bottom is a negative 1. So 3i minus 4 over negative 1. And of course, we always write the real portion first with the complex number. So it's a negative 4 plus 3i over a negative 1. And my negative can really make it a positive 4 and then a minus 3i. B will also be multiplied by an I. So this will be 4i minus 3i squared over a negative I squared. So 4i minus 3i squared is a negative 1 over negative times a negative 1. So 4i plus 3 over 1. And of course, the real number goes first, so it's 3 plus 4i. Now, the last few here, we're going to have to use a complex conjugate because we have a complex number. So it'll be 4 plus 5i over 4 plus 5i. So this will be 3 times 4 is 12 plus 15i over 4 times 4 is 16. The middle terms cancel out because they're complex conjugates. And we have a negative times a positive, so a negative 25i squared. The top is already simplified. The bottom is 16 minus 25. I squared is a negative 1. And so it's 16 plus 25. So this simplifies to 12 plus 15i over 41. And let's do D together, and then E will be on the extra video. So what is the complex conjugate that we need to multiply by? I'm going to let you take a minute and figure that out. That should be 5 minus 6i. So we have 10 minus 12i plus 5i minus 6i squared over 25 minus 36i squared. So on the top we have 10. Combining our like terms, we have a negative 7i minus 6 times a negative 1. On the bottom, we have 25 minus 36 times a negative 1. So simplifying a little bit more on top, we have 10 minus 7i plus 6. On bottom, we have 25 plus 36. And combining the constants on top, we have 16 minus 7i over 61. So catch me back for that little extra video if you'd like some more support.